Hi, welcome to the CodeUnion screencast on the HTTP request response lifecycle in the context of our Social Wall app. What we're going to do is we're going to run through some code, and we're going to look at how running that code on a server produces a website that we can look at and play with. The first thing I want you guys to do is head to Cloud9 and go ahead and sign into the accounts that you created into the setup process. Let's access our workspace. Here we are at our terminal. We can verify that we have all the code that we left off with. The first thing we want to do is run our server application, which we can do by typing ruby hello.rb -p $port all caps -o $IP all caps. Now our application is running at social wall -c9 your username.c9.io. It's kind of a crazy URL, but it's very useful because it allows us to run applications inside Cloud9 and view them on the internet. So let's break this out so we can look at it. And let's look at our terminal process. So the topic of this screencast is the request response lifecycle. And the first thing we're going to look at is the HTTP request. So if you'll notice, the left side of my screen is a terminal, and in the terminal we ran ruby hello.rb. Once we run that Ruby process, we now have an active, what you would call an internet server that's running. It's kind of like rubbing in an ambient state. It's waiting and listening for HTTP requests to come in from the internet. On the right side of my screen, you'll notice I have a web browser open that has some links displayed in it. These links are contained in the hello.rb code. And this https://social-wall-c9-startuplandia.c9.io is the internet URL that allows an individual to look at our server. And what I'm going to do is I'm going to click on this link, show me waffles, and if you'll notice in the terminal we'll get some activity. And what you should see, what I'd like to highlight, is that the server registers a GET request was made to /waffles, and this will become very important in the future. And I'm just going to click on the rest of these links to show what happens. If I click on show me chocolate, we're going to get a GET request to /waffles/chocolate. And if you'll notice, let's click on bake 10 cookies, but let's inspect this element and let's look at the underlying hyperlink. Notice that the hyperlink being displayed in Chrome, the href tag hyperlink reference equals /bake and bake_good equals cookies and count equals 10. So what we're doing here is dynamically inserting data into the URL, and I'm going to push Command K on Mac OS X, which is just going to clear our terminal. Our process is still running, it just clears the output in the terminal. Makes it a little bit easier to look at what's happening. So here I am clicking on bake 10 cookies, and as you can see, a GET request was made to /bake and bake_good equals cookies and count equals 10. You can see me highlighting it on the left, which was the URL that is listed in our browser. Here I am pushing back, going back to our links. Let's inspect this element one more time so we can see the relationship. When I clicked this link, the HTTP GET request was made to this endpoint on our server. Just to highlight some more activities, let's bake 5 cronuts. Notice we now got a GET request made to /bake, and bakegood equals cronut, and count equals 5. Let's go back one more time, and we have one more link that we can click on. Bake 1138 cupcakes, and we get a slightly different response back to the browser this time because we're hitting a different server endpoint. Anyways, that is a very quick look at how we can click links to generate requests. Now let's actually look at the code that was being run. What I'm going to do is I'm going to open up the code. In hello.rb, and let's look at what was happening. So in the case where we literally make a request to social-wall-c9-startuplandia.c9.io, excuse me, we are literally making what is called a request to the root of the application. You'll notice that we have a get slash, right, which is the code executed, is the HTTP request created by requesting the root of the application. And you'll notice inside hello.rb we have this line of code get, which is receiving an argument of a slash. Then these lines of Ruby code get run. HTML points to a string. We're concatenating some HTML into the string, and then we're sending that string back to the browser, which is what you're actually seeing. Let's look at this. Let's look at our page source. So literally, our server endpoint is sending this string back to the browser. The browser's interpreting this and converting it into what you would identify potentially as a web page. In the case of Show Me Waffles, let's look at where the hyperlink points to. The hyperlink literally points to /waffles. And here in hello.rb, if we make a GET request to /waffles, we are assigning HTML to a string, the variable HTML to a string that has some HTML inside of it, and literally we are sending that string back to the browser. And if I click Show Me Waffles, we can see the entire contents of the response is literally an h1 tag. It's identical to what we have on our server. Get /waffles/chocolate is pretty much the same as /waffles, except that we have added some detail to our server endpoint. So instead of requesting /waffles, we're requesting /waffles/chocolate, and again we're assigning a local variable to a string, and then we're concatenating some more information into that string, and then we're literally sending the string back to our web browser. Let's go ahead and click on /waffles/chocolate. you notice this text being displayed in the browser is identical to the text that we have inserted into our string on the server. Okay, now we're going to look at the server endpoint associated with /bake. And if you'll notice in our code, we have the local variable count, which is being set equal to params count, and we have the local variable bake_good being set equal to params baked good. The important thing to notice in this situation is that params is a hash that Sinatra gives us, and the hash contains data that has been dynamically added to our HTTP GET request when the request is made in the client, and the params hash is incredibly important because it is the entity that carries dynamically generated user input from the client to the server. And in this case, we're setting our two local variables, count and baked good, and then we are actually using some straightforward Ruby iteration to dynamically generate as many times as we have indicated by the count list item. Inside the list item, we're interpolating some other dynamically provided value, which in this case would be the type of baked good, and in this case num indicates the individual time that we have repeated or sequentially executed this line of code, in which case if we were to request 10 baked goods, num would represent the digits 1 through 10, and it would be dynamically inserted into the HTML. Then we're closing our HTML with our unordered list tag, and then we're sending all of this information back to the browser. That was certainly a mouthful. Let's see how this plays out in reality. Let's inspect the element of this tag. Notice we're going to make a request to /bake _bake_good equals cupcakes and count equals 1138, which will, let's just clear our logs. Again, we're not turning off our server, we're just clearing the output. Let's make our GET request, and we can look at our terminal in the right. And notice we made a GET request to /bake !, which the question mark is important because it indicates the beginning of dynamically inserted query parameters, and baked_good equals cupcakes and count equals 1138, and the response back to the browser was literally the first line of our HTML, I'm going to bake, and then 1 up to count do num is Ruby speak for as many cupcakes as we request, create this list item that dynamically inserts the count and the item. And if we were to look at our source, let's view page source, you'll see we have quite a lot of list items inserted into our HTML document. So that is most certainly a decent amount of complexity, highlighting the nature of the request and the response lifecycle of a small Sinatra app. The goal of this screencast is not to have you to become an expert on what just happened. It's to help you build awareness and experiment with this code. If you find yourself trying to run this code and for some reason things don't work, please email us stuck@codeunion.io, and we will try to help clarify what is happening and get you unstuck. Happy coding.